The province of Ravenna has embarked on an essential project aimed at improving the safety and functionality of the infrastructure along the former SS 306 Castellana. This project involves rationalization and safety upgrades, focusing specifically on eliminating critical points that could pose risks to users. Currently, the project is in its second stage of Phase 1, where attention is given to laying the bridge beams, a significant milestone in the overall improvement works. The beam laying process commenced promptly at 9 a.m., signaling the start of a carefully orchestrated operation that had been meticulously planned in advance. The installation of 5 beams, each an impressive 36.60 meters long and weighing 80 tons, would take place over a period of 6 hours. Given the sheer size and weight of these beams, transportation to the site presented a significant logistical challenge. Specialized transport vehicles, each measuring 41 meters in length, were employed to move the beams from their point of origin to the bridge site. Maneuvering such large vehicles along the narrow roads required precise coordination, ensuring safe and timely delivery. The heavy beams were delicately offloaded and positioned for installation, a process that demanded both technical expertise and careful timing to ensure that the project proceeded without delays or safety issues. The beam laying process was a testament to the intricate planning and collaboration involved in large-scale infrastructure projects. The bridge structure itself presents its own set of challenges, including a 6% slope, which adds an element of difficulty to the installation process. This gradient results in a vertical difference of 2.10 meters, requiring precise calculation and careful handling during the laying of the beams. Despite these challenges, the installation is being carried out using advanced equipment designed to handle such heavy and lengthy components. At the heart of the beam laying operation is an 800-ton capacity crane, a highly specialized piece of machinery essential for handling the immense size and weight of the beams. This crane, with its exceptional lifting power, is capable of precisely raising and positioning the 80-ton beams, ensuring they are aligned correctly within the structure. The crane's outreach extends to a maximum of 24.0 meters, allowing it to cover a wide radius and reach the necessary points on the bridge without repositioning. Its capacity and extended reach are vital for navigating the bridge's 6% slope, ensuring that the beams are placed securely despite the challenging incline. The precision and strength of this crane are crucial in maintaining the stability of each beam during installation, preventing any misalignment and ensuring the long-term safety and integrity of the bridge. The installation of the large block on the left bank of the Shinmachigawa Bridge, part of the Shikoku Transversal Expressway, represents a significant engineering feat. This task was accomplished using the crane ship Musashi, known for its massive lifting capacity of 3,700 tons. The bridge itself forms a key part of the expressway, which serves as a critical link in the infrastructure connecting the various regions of Shikoku, an island located in southwestern Japan. The large block installation is an important part of the construction process and requires precision and meticulous planning due to the sheer weight and size of the structure. The use of a floating crane like Musashi was essential for this task, as conventional land-based cranes would not have the capacity or flexibility to handle such a massive load over water. The crane ship Musashi is specifically designed for these types of operations, making it one of the largest and most powerful floating cranes in Japan. Before the installation, engineers carefully planned the lifting procedure, taking into account factors such as weather conditions, tidal changes, and the structural integrity of both the bridge and the block. The process involved securing the block to the crane ship, positioning the ship correctly in the river, and then carefully lifting the block into place. This precise operation required coordination between the crane operators, marine engineers, and structural engineers to ensure the block was placed with millimeter accuracy. Once the block was successfully lifted and installed, it marked a major milestone in the bridge's construction. The success of this operation demonstrated the capabilities of Japan's advanced engineering technology, as well as the importance of using specialized equipment like the Musashi for large-scale infrastructure projects. Main cable erection for the 1915 Çanakkale Bridge, August, September 2019. The construction of the 1915 Çanakkale Bridge marks one of the most ambitious engineering projects in the world, setting a new global record as the longest suspension bridge. Spanning a total length of 4,163 meters, the bridge connects the European side, Gallipoli, with the Asian side, Lapseki, across the Dardanelles Strait. Its impressive dimensions, which include a 2,023-meter main span, make it a modern marvel of civil engineering. This milestone project is part of the broader Malkara-Çanakkale motorway, which will enhance the region's transportation network. The main cable erection phase, which began in August 2019, is critical in shaping the overall structure and supporting the deck of the suspension bridge. Anchor blocks and approach viaducts. By August 2019, work on the 1915 Çanakkale Bridge had reached significant milestones, with much progress being made on both the Lapseki Asian and Gallipoli European sides. The production of anchor blocks, which are key components for securing the main suspension cables, was completed on both sides. These blocks provide the necessary counterbalance to the tension forces exerted by the main cables that will support the bridge's deck. Concurrently, work on the approach viaducts on both sides was progressing. The approach viaducts act as transitional structures, connecting the bridge deck to the land on both ends. The European side, near Gallipoli, featured a 680-meter viaduct, 91% of which was completed by this time. Meanwhile, the Lapseki side boasted a shorter 68-meter viaduct, which was 68% finished by the end of the summer. The completion of these viaducts was vital to the overall timeline of the project, with deck construction for these structures planned to begin using the push-rub method. This method of deck construction enables continuous, incremental advancement of the deck over the supports, a technique that increases construction efficiency and minimizes disruption to existing infrastructure. On the Asian side, deck manufacturing was slated to begin in January 2020, while on the Gallipoli side, the deck construction was scheduled to start in September 2020. This structured schedule reflected the high level of planning and coordination required to manage such a large-scale project. Highway construction. The 1915 Çanakkale Bridge is not an isolated structure, but part of a larger infrastructure project, the Malkara-Çanakkale Motorway Build-Operate-Transfer Project. This motorway is crucial for facilitating transport between the Kanali-Tekirdağ-Çanakkale-Sevastopol route. The highway construction spans 103 kilometers, with 89 kilometers located on the European side between Malkara and Gallipoli, and 14 kilometers on the Asian side near Lapseki. By August 2019, significant progress had been made in terms of earthworks and foundation preparation. Of the 11 million cubic meters of excavation required, 3.5 million cubic meters had already been completed. Additionally, 7 million cubic meters of the necessary 26 million cubic meters of fill had been successfully deposited. The massive volume of earth moving required highlights the complexity of the project, as the site preparation for both the bridge and the highway required vast amounts of materials to be moved and reshaped. In parallel, concrete works for the highway's art structures, bridges, underpasses, and retaining walls were well underway. Out of the 500,000 cubic meters of concrete required for these structures, 200,000 cubic meters had already been poured. By August 2019, the overall highway project had reached 16% completion, reflecting the steady pace of progress. Bridge tower construction, one of the most visually striking aspects of the 1915 Çanakkale Bridge construction, was the erection of the massive bridge towers. These towers, which will eventually reach a height of 318 meters, are crucial for supporting the suspension cables that will bear the weight of the bridge deck. Work on the tower caissons, the massive base structures that anchor the towers to the seabed, began earlier in 2019. These caissons, measuring 74 by 83 meters in size and 15 meters in height, weigh an astonishing 51,186 tons. By early 2019, the construction of the tower caissons in a dry dock had been completed, and they were then ceremoniously transported to a wet dock in May of that year. From there, they were sunk into their final positions in the Dardanelles Strait, where they now form the foundations of the bridge towers. By August 2019, 8 blocks of the steel shafts had been successfully placed atop the caissons on both the Gallipoli and Lapseki sides of the bridge. These blocks formed the rising legs of the towers, which by this point had reached a height of 84 meters. This represented a significant milestone, as the towers must eventually reach 318 meters in height before they are capped with decorative elements symbolizing the famous artillery shell lifted by Turkish soldier Seyit Onbaşı during the Battle of Gallipoli. Next steps in construction. As the summer of 2019 drew to a close, construction on the 1915 Çanakkale Bridge was progressing at an impressive pace. The next critical phase of construction, scheduled to continue through 2021, would focus on the erection of the main cables. These cables, which would eventually stretch across the Dardanelles, are the heart of the suspension bridge, supporting the entire span of the bridge deck. Following the completion of the towers, workers would begin spinning the main cables, a process that involves the continuous winding of steel wire strands between the towers. Once the cables are in place, the deck segments of the bridge will be lifted into position, completing the structure of the bridge. The 1915 Çanakkale Bridge, upon completion, will stand as a testament to modern engineering capabilities and Turkey's commitment to improving its infrastructure. The August-September 2019 period was a crucial time in the project, as it marked the completion of key components like the anchor blocks, tower caissons, and viaducts, setting the stage for the next phases of construction. 1915 Çanakkale Bridge, Logbook. June to July 2020, the construction of the 1915 Çanakkale Bridge stands as a significant milestone in civil engineering and global infrastructure. As part of the larger Malkara-Çanakkale Highway project, this bridge, situated over the Dardanelles Strait in Turkey, symbolizes the integration of Turkish heritage with advanced construction technology. By connecting Europe and Asia across the strait, it is set to be the longest suspension bridge in the world, with a span of 2,023 meters between its two towers. The construction of the bridge reflects not only Turkey's ambitions for economic growth, but also the monumental efforts required to achieve such a feat. The logbook entries from June to November 2020 provide insights into some of the key stages of the construction process, highlighting the challenges and achievements of this remarkable project. June 2020. Reaching new heights with the crane towers, the focus of the construction during June 2020 was on one of the most crucial elements of the bridge, the towers. These towers would not only support the entire weight of the bridge, but also form its iconic visual identity, symbolizing strength and innovation. The team's efforts during this phase were particularly focused on elevating the cranes and completing a critical lifting operation, which would go down in the record books. After months of preparatory work and successive stages of construction, the cranes were finally climbed to their maximum height of 328 meters. These towering cranes, designated as M2480Ds, played an essential role in lifting the colossal components of the bridge into place. Standing 328 meters above the waters of the Dardanelles Strait, these cranes marked an engineering feat by themselves, enabling the lifting of massive structural sections that would otherwise be impossible to move into position. One of the defining moments during this month was the installation of the upper crossbeam, UCB. This section, weighing a staggering 155 tons, had to be lifted with extreme precision to its final resting position atop the bridge towers. Although the lift itself took approximately 30 minutes, the extensive planning and coordination that went into this singular event spanned months of preparation. Every detail, from wind speed to crane stability and structural alignment, was carefully measured to ensure a flawless lift. This lift not only marked a major step forward in the construction, but also set a new world record. Lifting a 155-ton section to such a height was unprecedented in the field of crane operations, breaking the record for the heaviest lift at such an altitude. It showcased the technical prowess of the team and the capacity of modern engineering to push the boundaries of what is considered possible. The successful completion of the UCB lift in June paved the way for the rest of the summer's construction activities. However, the complexities of the project were far from over. With the cranes now stationed at their peak heights, the challenge would be to utilize them effectively for the next stages of construction while ensuring the safety and efficiency of operations. July to November 2020. Completing the bridge towers as construction progressed into the latter half of 2020, the pace of operations continued to intensify. The focus shifted from raising the cranes to completing the bridge towers, a monumental task that required relentless effort and precise coordination. The DLSY JV team, working as the contractor for the project, implemented a round-the-clock schedule, with both M2480D cranes operating at an average of 20 hours per day. This intensive utilization of the cranes reflected the sheer magnitude of the work ahead. Between July and November 2020, the team successfully completed the bridge towers ahead of schedule, a testament to the efficiency and expertise involved in the project. This was no small achievement, given the complexity and scale of the operation. The M2480D cranes were employed in an array of heavy lifting operations, including some of the most challenging and weight-intensive lifts seen in construction projects worldwide. Throughout this period, the following major lifts were completed: 8 lifts, each weighing 160 tons. These massive sections, forming integral parts of the tower structure, required careful handling and positioning. The crane operators and ground teams worked in unison to ensure that each lift was conducted with the highest level of precision. 36 lifts of more than 150 tons each. This phase involved a variety of structural components, all critical to the bridge's integrity. These heavy lifts underscored the importance of reliability and meticulous engineering in achieving the project's goals. 208 lifts weighing over 100 tons each. While these were relatively lighter compared to the 160-ton lifts, the sheer volume of such operations highlighted the complexity and ongoing intensity of the work. With over 200 lifts of this size, the team demonstrated a tireless commitment to completing the bridge towers ahead of schedule. As the towers reached their final stages of construction in November 2020, the cranes had fulfilled their purpose. Their towering presence, which had been a central feature of the skyline over the Dardanelles Strait for several months, was no longer needed. The MT480D cranes, having played their part in one of the most challenging phases of construction, were carefully climbed down the completed bridge towers and safely dismantled. This marked the end of a critical chapter in the bridge's construction, but much work still remained before the project could be fully completed. Conclusion: a world-class engineering achievement, the period from June to November 2020 was a pivotal time in the construction of the 1915 Çanakkale Bridge. The successful completion of the tower construction, punctuated by record-breaking lifts and relentless work schedules, demonstrated the incredible technical and human effort required to bring this project to life. From the installation of the upper crossbeam in June to the final dismantling of the cranes in November, the achievements of these months laid the foundation for the completion of the bridge, which will stand as a symbol of Turkey's growing infrastructure and and economic ambitions. With its towers completed, the bridge entered the next stages of its construction, which included installing the suspension cables, decking, and various other elements that would eventually turn this engineering marvel into a functioning roadway, linking two continents and solidifying Turkey's place in the world of modern infrastructure. The 1915 Çanakkale Bridge stands as a remarkable feat of engineering and a significant landmark in Turkey. Located in northwestern Turkey, it spans the Dardanelles Strait, linking the provinces of Çanakkale and Gelibolu. The bridge is strategically positioned approximately 10 kilometers, 6.2 miles, south of the Sea of Marmara, enhancing connectivity in the region. Officially inaugurated on March 18, 2022 by President Recep Tayyip Erdogan, the bridge took around 5 years to construct, with a main span of 2,023 meters, 2.023 kilometers, 1.257 miles. It holds the title of the longest suspension bridge in the world, surpassing the previous record set by the Akashi Kaikyo Bridge in Japan by 32 meters, 105 feet. This engineering marvel not only showcases Turkey's capabilities in modern infrastructure, but also aims to boost regional economic growth by improving transportation links. The bridge serves as the centerpiece of the planned O6 motorway, a significant infrastructure project that will span 321 kilometers, 199 miles, and connect the O3 and O7 motorways in East Thrace to the O5 motorway in Anatolia. This integration of motorways will facilitate smoother trade and travel across the region, enhancing Turkey's logistical capabilities and overall connectivity. The name 1915 holds historical significance, commemorating an important Ottoman victory during the Gallipoli campaign. This campaign involved a naval engagement followed by a land invasion by forces from Australia, New Zealand, France, and Great Britain, beginning on April 25, 1915. The campaign was crucial in the context of World War I, and the bridge's naming serves as a tribute to the sacrifices made during that period. The 1915 Çanakkale Bridge is the first fixed crossing over the Dardanelles and the sixth crossing across the Turkish Straits, following 3 bridges over the Bosphorus and 2 tunnels beneath it. Its construction reflects Turkey's ambition to strengthen its infrastructure while honoring its historical legacy. As it stands today, the bridge not only connects 2 sides of a strategic waterway, but also symbolizes a bridge between Turkey's past and its future aspirations.